If you add first n positive integers, the result will be n times n plus 1 over 2. Whatever number n you pick, if you add 1 starting from 1 and going up to 100, you will obtain 100 times 101 n plus 1 over 2. In this case, n plus 1 will be 101, and the result is n times n plus 1 over 2, 100 times 101 over 2. So 102 cancels, we end up with 50. 50 times 101 is 5050. The proof of the formula is in a following presentation, but let's concentrate on using this formula in this presentation. So what if you had a sum not starting from 1 but an arbitrary number, for example 45, like in this example, and each term is 1 more than the previous term, namely the arithmetic finite arithmetic series, which increases by 1 in each following term. Of course, you cannot use the formula directly, since the formula gives the sum from starting from 1 and going up to n. In this case, you will use the formula twice, like that. So you write the sum starting from 1 and going up to your last term. You call this the sum S1, you call this sum S1, and define another sum S2, which is up to your actual sum's starting number, 1 less than this actual starting number, and you call that sum S2, and so your desired sum becomes S, which equals S1 minus S2. In this case, S1 is the sum starting from 1 up to 77, which is 77 times 78 over 2. It equals 3003. And the sum S2 starting from 1 and going up to 44 equals 44 times 45 over 2, which is 990. So our final answer is S is S1 subtract S2 from S1, and you get 3003 minus 909, which is 2030. Now please get your hands dirty and do this exercise. You will first compute the sum starting from 1 and going up to 58, and then you will compute the sum starting from 1 and going up to 21. You subtract these from the second one from first, and you will compute the desired sum.